Natural materials were always utilized as a part of many sports activities. Natural rubber was a key element of the ball game o juego de pelota, which was a sport with characteristics of ritual ceremonial performed by the ancient Mayan civilization. Wood was also used in javelin sport as a part of Olympic Games. Similar participation for natural materials such as stones and bronze or other metals for discus throw sport in Olympic Games. Finally, a special mention for gut strings in archery, badminton, tennis during ancient civilizations and also modern times. As technology evolved, materials technology dramatically changed, bringing new options for those traditional sports. For example, balls used as a main element in multiple sports started to be manufactured using polymers such as PVC, polyurethanes, latex, and special elastomers. One of the most extraordinary evolution process was observed in shoes applications, shifting traditional materials like leather and vulcanized rubber to polyurethanes, EVA, nylon, TPU, and TPE compounds, where multiple materials were developed for upper and the sole of the shoe, not only making a lighter product, but also keeping and even improving performance. There are multiple examples as a part of this very fast evolution process. Golf balls using polystyrene. High-performance graphite composites in tennis rackets. Polyester and nylon in tennis strings. Where transparency is an issue, materials such as polycarbonate and fluoropolymers are found as preferred materials. But not only specific active elements are produced using a broad range of polymers, polymers are also preferred materials for structural sports applications for multiple reasons such as lightweight, washability, and low maintenance. Stadiums, facades, and turfs are currently being built using several polymers as primary materials. During this presentation we will be showcasing a variety of polymers and their corresponding producers in order to highlight products and applications that are part of this universe of activities. Polyurethanes in sports applications. The picture shows a super elastic foam for lightweight running shoes. Through its sealed air cells of expanded thermoplastic polyurethane, BASF's new Infinergy foam makes shoe soles very elastic and effectively absorbs shock impact while jogging. A special sneaker was the 2014 winning design in a design contest that the School of Footwear Design and Technology in Capriccio di Vigianza near Padua, Italy, has now held for the 8th time. The design is composed of an elastopin polyurethane sole, with 2 elastolin inserts covered by an elastolin film. Every BASF's foam has been developed for a specific application, to achieve a particular performance. Like for example this elastogran-based compression-resistant polyurethane foam. Researchers at BASF subsidiary Elastogran have developed a special polyurethane foam by adding 1 to 10 micrometer-sized carbonyl iron particles. The new technology makes it possible, for example, to precisely adjust the compressive strength of shoe soles. The tiny iron particles are incorporated to the polyurethane during production, while it is still liquid. Here we have a picture showing a low-density polyurethane structure. In conventional running shoes, the cushioning starts to deteriorate after just a few kilometers. If the midsole is made of low-density, open-cell polyurethane foam, the shoe can maintain its performance for a long period of time. Another innovative company producing unique polyurethane solutions for the footwear industry is Lubrizol, offering its new estane-based TPU solutions through its Bouncil X microcellular TPU foam containing Lubrizol estane TPU. Bouncil X benefits include lightweight, outstanding long-term cushioning, thin solid skin for durable TPU performance, hardness, and energy absorption return. High-efficiency injection molding process with overmolding feasibility, use of industrial regrind or post-consumer recycling possibility due to no cross-linking or chemical blowing agents in foaming process. Lubrizol makes a really light product, keeping the performance with a density ranging between 0.27 to 0.30 to 0.61 to 0.66 to cover approximately 80% of the total market foam demand. Note that we are talking about a huge expansion, which is remarkable as mechanical properties are kept. Lubrizol TPU is an environmental-friendly product, as it is a non-cross-linked product, and is not chemically foamed. As Lubrizol TPU is not cross-linked, it can be recycled 100% of post-consumer products. Another company offering a wide range of two-components polyether-based systems for sports footwear applications is Covestro. Covestro is a former Bayer company. Covestro offers its Bayflex 250, 950, and 960 series. Bayflex 257 is used in the outsole system of dual-density polyether shoe soles, translucent to opaque. Series 950 and 960 are used in the manufacture of microcellular polyurethanes inner sole, providing to soles prepared from those components with lightweight, comfort and durability. Polycarbonate resin sheet helps to meet the needs of architects and designers for sports facility applications. Whether the project involves vertical or overhead glazing for translucent or transparent daylighting, polycarbonate materials help designers to create shapes that would not be possible with glass. Applications include canopies, facades, security windows, shelters, and skylights, to name just a few. Covestro produces the Macrolin PC brand to provide impact resistance and strength, excellent thermal stability, weatherability, high transparency, abrasion resistance, and cold formability. Polycarbonates are also used in protective sports applications such as performance glasses and goggles, helmets, and masks in many sports: badminton, baseball, bicycling, fencing, hockey, football, handball, hunting and shooting, lacrosse, paintball, racquetball, skiing, and snowboarding, squash, swimming and diving. Now we will talk a bit about a new generation of synthetic elastomers in sport applications, polyether-based polymers produced by Arkema. Pebax TPE is an ultra-performance elastomer used by leading sports equipment brands such as Adidas, Nike, Puma, The North Face, etc. Sports shoes represent one of the premier markets for Arkema Pebax elastomer. Its unique combination of toughness, elasticity, lightweight, and flexibility allows the manufacture of soles that bring performance, comfort, and precision to sports footwear. On the market for over 30 years, constantly renewed and improved, Pebax is a high-performance thermoplastic elastomer featuring a unique array of sought-after properties: lightweight, energy return, flexibility, elasticity, fatigue resistance, impact resistance. All customized and fine-tuned by changing the ratio of its two components, polyamide blocks, for rigidity, and polyether blocks, for flexibility. Over the years, Pebax has won over leading sports brands, including Adidas, Nike, Puma, The North Face, Babolat, and Mizuno, who have used it to design the soles of their football, rugby, running, tennis, and trekking shoes and boots, as have Scarpa, Dinafit, Fisher, and Scott, for their ski boots. Widely praised for their outstanding properties, Pebax soles enhanced the performance of over half the soccer players in the Brazil 2014 World Cup. Pebax Renew, a biosourced elastomer produced by Arkema, has been selected by Sony for its original soccer ball, named Join the Team. Specifically developed for donation to children in Africa on the occasion of 2010 South Africa Soccer World Cup. This ball features a dual-layered surface, one of them being in Pebax Renew, which brings 1.6 times higher durability than conventional soccer balls. Pebax Renew is a high-durability thermoplastic elastomer, partially made from non-edible renewable resource castor. We can find several applications seeking natural-based materials substitution, and one of the most interesting is bicycling, where the use of nylon as a metal substitute really empowered design and creativity. The BASF's Concept 1865 is a clear example of this process, where 1865 bike design was updated under the banner of new materials for new ideas. Velocipedes were known for their enlarged front wheel that improved the transmission ratio. The result, a sleek, lightweight, electrical bike that is literally reinventing the wheel for inspiring the future of mobility and compensating the disadvantages of the original design by using 24 different BASF innovative plastics. The present-day velocipede rider can be assisted by an electric drive, as seen on the picture. Here we can see the prototype presented by BASF at AmericaPlast 2015. The seat of the Concept 1865 is detachable and contains the battery for the electric drive. Ultramid DMGH was used in pedals and cranks, Ultramid Strucutrin rear wheel rim, and Ultramid B in the production of the e-motor cover. Polyamides are also used in other sports such as skiing, ski binding, and in some tennis strings. We can also find polyamides in the production of high-performance transparent polyamide, like the Rilson Clear G350 produced by Arkema. Here we see Evolve ski sunglasses collection from Smith Optics using Rilson Clear Renew. New Evolve sunglass frame models are entirely made of Rilson Clear Renew, a biorenewable sourced polymer derived from castor oil. Dow Chemical, worldwide Olympic partner, is one of the polyolefin manufacturers really committed to sustainable innovation, providing several solutions for Olympic Games on the field of play to improve the athlete's experience. One great example is the artificial turf application. The artificial turf, which is based on the company's polyethylene and polyurethane, will be the official playing surface for hockey competitions during the Rio 2016 Olympic Games. The playing surface consists of specific high-performing materials formulated together in multiple layers. The surface system is designed to deliver enhanced durability for increased pitch life and a consistent field of play throughout the busy Olympic competition schedule. The production of synthetic turf is a highly elaborated process. The system begins with the production of the master batch and the yarn for the turf. The subsequent tufting and backing process provide a strong turf bind even when the surface is wet. For the upper surface layer, the polymer yarn provides wear resistance and energy absorption, combined with softness and speed. The complete turf system, including embedded shock pad properties, provides stability, durability, shock absorption, and force reduction properties for the benefit of the players and the game. Professional tennis strings are produced with polyester resins through an extremely critical extrusion process. Nicieza Taverna, headquartered in Chivilcoy, Provincia de Buenos Aires, Argentina, is one of the most important filament manufacturers in the marketplace, providing professional circuit players with high-performance strings. The polymer and a precise proprietary extrusion process enable the string to provide power and versatility for maximum stroke efficiency, and polyester is the best material for this very specific application. Transparency, environmental resistance, lightweight, mechanical resistance, and low maintenance are some of the properties sought by architects and designers of sports facilities. Fluoropolymers offer an outstanding alternative for the construction of coverage of large structural areas. Several sports stadiums are already being built using those type of polymers. AGC Chemicals, a leading developer of high-performance fluoropolymer resins, produces the FluenETFE fluoropolymer resins, which has provided a key architectural component of many world-class stadiums such as Arena Pernambuco, one of the new stadiums built for the World Cup Brazil 2014. To ensure the desired lifetime of usefulness, Arena Pernambuco, in the coastal city of Recife, was designed and built to be part of the Cup City. It is a 1 square mile zone of residences, offices, and entertainment venues. To integrate the stadium into this zone, and ensure its attractiveness over this lifetime, the innovative stadium facade was constructed of FluenETFE high-performance fluoropolymer film. This unusual material gives the stadium a futuristic rounded appearance and transfers natural light inside the facility, reducing its dependence on electricity. Approximately 25,000 square meters of AGC 0.25 mm thick FluenETFE film was used across the arena's exterior. FluenETFE film has been used successfully for years for membrane structures and architectural facades, including commercial buildings and sports facilities in Europe and Asia. ETFE film provides superior weatherability, allowing it to withstand extreme temperatures. ETFE also exhibits excellent thermal stability, chemical resistance, transparency, and non-sticking properties. One additional advantage of using ETFE film is tear strength. It will not easily rip or scratch over time. FluenETFE film provides better than 90% light transmission. This allows sunlight to penetrate into the stadium's walkways and common areas, while preserving a tempered atmosphere inside. It also gives facility operators to create dramatic visual effects using installed backlighting that will show for miles outside the stadium. ETFE film is also lighter than glass, which gave the designers flexibility to create a functional building that is also visually appealing from the outside. It is also surprisingly strong, with a maximum tension of 3.5 kN per meter, so its strength-to-weight ratio is favorable compared to glass. The installation at Arena Pernambuco started by erecting an extruded aluminum channel frame tied into the building's structure. The film segments were then installed using rubber packing to hold it in the channels. Workers then snapped and screwed aluminum finish plates onto the frame sections. Plastic transformation machinery is also a key element to be incorporated as part of the sports goods manufacturing process. Arberg, one of the market leaders in the manufacturing of machinery for the injection molding of thermoplastic resins, has developed strong collaborative partnerships with sports goods manufacturers. Framis Kunststofftechnik GmbH, a global manufacturer of high-performance components for the sports, produces socks shoes for all the major producers of soccer boots worldwide such as Adidas, Nike, Puma, etc. Virtually all soccer boots contain functional parts made by Framis, and practically all of those components are produced by Framis using Arberg's all-rounder injection molding technology. The Arberg All-Rounder T, a 3-components rotary table machine, was specifically designed for the volume production of footwear components. Finally, we will show a very interesting application. A paraglider harness which incorporates an ultra-strong sandwich composite made with honeycomb core from Econcore. This composite material from Tepextinalite, a Lanxess subsidiary bond laminates, is performing excellent even in extreme sports applications. The harness S footboard is made of a sandwich composite just 1 cm thick, comprising thin Tepex facings measuring just 0.5 mm and a polypropylene honeycomb core from Econcore NV.